This lesson is to go over the properties of transformations. So we're first going to talk about congruency. You need to know when figures are congruent. So if a transformation produces an image with the same size and shape as the pre-image, the image that you're starting with, the figures are congruent. The symbol that we use for congruency is an equal sign with a little squiggly, it's called a tilde above it. So in this statement right here, if we want to say the triangles are congruent, we would say ABC is congruent to A prime, B prime, C prime. So that's congruency. If they're not congruent, they could be similar. We're going to go through what similar means. So if a transformation produces an image with proportional, not the same size, but proportional sizes, proportional sides, and the angles would still be congruent, then we call these figures similar. So those are the two different categories, congruent, similar. So the symbol for similar is just the tilde, not the equal to. So as you can see, these two triangles right here, they are not the same size, but we're going to say that they're proportional in their sides, and we would need numbers to actually prove this, but this is for example purposes, that we would say triangle ABC is similar to triangle A prime, B prime, C prime. When we're talking about congruent, the transformations that make congruent figures are translations, reflections, and rotations. Similar would be a dilation, where the sides stay proportional, but the sizes the sides stay proportional, but the size is different. And I'm just going to go through a couple examples to show you that. So in example 1, we have triangle ABC, and then we have triangle ABC here. As you can see, the A is on the outer side here. Everything is, the B and the B prime are equidistant from this y-axis right here. So just to describe this transformation, this is a reflection across this y-axis right here. The corresponding side lengths, so this side length, it corresponds to this side length right here. AB corresponds with A prime, B prime. BC corresponds with B prime, C prime, and then AC corresponds with A prime, C prime. All of these sides are congruent, means they're the same length. So to write a similarity or congruent statement, we're going to pick congruent, and we're going to write triangle. Sometimes you can put a little triangle. ABC is congruent to triangle A prime, B prime, C prime. We also know this because it's a reflection. Reflections, rotations, and translations result in congruent figures. So now we're going to talk about this transformation. So we're starting here with this triangle ABC, and then A prime, B prime, C prime is bigger. So this is going to be a dilation. We're going to figure out a dilation by what. So what I'm going to do is I'm going to write the coordinates. So A is, no, it's not 0, -1, 0. And it went to A prime, which is -3, 0. So I'm looking for this relationship here. And it looks like we're multiplying by 3. So this is going to be a dilation. with a scale factor of 3. So what do we notice about the corresponding side lengths? Well, the side lengths are going to be proportional. The angles are still congruent, but that means that, so let's see, let's write sides proportional. A dilation will always, this is shorthand for angles, they are congruent. A dilation will always result in congruent angles. So when we write a similarity or congruency statement, these are similar. They're not congruent because they're not the same size and shape. So we're going to write triangle ABC is similar to triangle A prime, B prime, C prime.